again. Here's question 33 from the 2014 exam. We have the graph of this function, which is this lot, and it seems to come in these different parts. Okay, let's just go down and see what the actual question is telling us to do. Right, part A, determine f dash of x, or the derivative for first part when we're less than 0. So let's do that. Less than 0. Less than 0 is this first one here, and the derivative of the f dash of x of that, well, the derivative of that is just 2x, so that looks pretty straightforward. When we're greater than 0 and less than 1, that must be the second bit. Let's go up again. Greater than 0 and less than 1, greater than 0 and less than 1. Well, if the function is 1, so the derivative of that, just being a number, the derivative is 0. Greater than 1 and less than 2. Yep, between 1 and 2, there we go. We've got x, the derivative of x is just 1. Greater than 2. For greater than 2, that's the last one here, we've got this. Okay, to find the derivative of that, you need to put that into index notation, so that is 2 into x minus 1 to the power of half. And now, that's f of x, now to the derivative of that. That is, we bring, the 2 is still there from the front. You bring the power to the front, so times a half. Whatever's on the inside, to the power 1 less than that, 1 less than a half is minus a half, all multiplied by the derivative of the inside part. Now the derivative of the inside part, x minus 1, is just 1. And making that all look a little bit neater, the 2 on the bottom divides into the 2 on top once, and we get just ones, all ones except for the x minus 1 to the negative a half. So that is the derivative of that part. So we get x minus 1 negative a half. I suppose I should have done that differentiating in this section here, but anyway, I've done it up there instead. Alright, I might as well keep going with part B. State the value of x for which the derivative f of x is not defined. Okay. Right, well, the derivative is not defined at this point here, that is when x equals 1, because you can see it's got a pointy bit there. It's not a smooth joining of those two parts of the graph. If it's not smooth, we can't differentiate, we can't find the gradient at that point, so that'll be at x equals 1. We also can't find the derivative of that point there, because the point x equals 2, you'll see is not defined. If either less than 2 or greater than 2, the point x equal to 2 is not defined, and so you can't find a derivative at a place there isn't actually a function. So they're the only 2 points. So we've got x equals to 1 and x equals to 2. We do, with these ones, always read all the questions. We've found the values where it's not defined, but you must include something to justify your answer. You can't get full marks if you don't answer all the questions. So the reason we can't have it at x equal to 1 is that the graph is not smooth at that point. There's probably other ways you could describe that, but the gradient, as they approach that from different points, is different. You know, the gradient of that will be something different to the gradient of that as we approach that point. But I think for here in this course, not being smooth should be sufficient. And the second one, well, that derivative is not defined because at x equals 2, the function is not defined for x equal to 2. And that is